So for activity number 2, we're going to be using a couple of very simple materials to demonstrate 2 key points, one of which has nothing to do with force of motion, and that is the idea of persistence and getting your kids to stay with something even though they have initial failure. So this activity does a variety of things with that, as well as teaching a little bit of force of motion. In this case in particular, we'll be talking about balanced forces. Now, when something is balanced in terms of forces, the object is not moving. So this table, for instance, has balanced forces acting on it. I know that because it's not moving. Okay, so we have gravity pushing down on the table at a constant rate in this case, and we have the table legs themselves pushing back against that gravity, and they are balanced, and so therefore nothing is in motion. Imagine 2 kids on a tug-of-war rope, and if they're equally matched, and they're pulling in the same strength, the same direct or opposite directions, then the middle of the tug-of-war rope is going to show no motion. So if the forces are balanced, you get no motion. In this case, we're going to literally balance something. What we want to get kids to do is balance a coin on the top edge of an index card. Now, you can use any size index card, you can use any size coin. When you show the trick the first time, the kids are going to probably want to go to a smaller, lighter coin, thinking that helps them balance. They are wrong. Okay? This is really good, though, because one of the things you need your kids to do is face cognitive dissonance, and that's when the idea they think is going to work, or the way they think things work, is wrong. You can tell them that is not nearly as effective as them learning this themselves. So this is also a good training method for you in not giving the answer. So give hints, help them and nudge them in the right direction. Do not give them the answer, even if it takes longer than you feel comfortable with. Right? Most teachers can go a few seconds before they start opening their mouths and giving answers.
Yes.
Don't do it. Your kids will be smarter and be able to better think through situations if you're not constantly giving them the answer. So here's the thing. And you can tell them straight up, this is a trick. Okay? So they need to be creative in their thought process. You're going to balance this coin on the flat edge of this card. There's one simple rule. When you're done, the card is flat, so you're holding your hand like this, and the coin is balanced up top. And no, you can't like put your finger behind the coin and say, oh yeah, there it is. You can't do it. You should have your 2 hands on the coin, on the card like this, and the coin should be balanced if they've done it right. So normally they sit on the table and they try it. And if they've done it right, they will be able to pick this up. They will be able to slowly walk around, and the coin will still be balanced, which of course blows their mind. But it's certainly possible. I have done this with first grade classes, and while it took them a long time to do it, they were able to do it. This is not about gross motor skill or fine motor skill necessarily. This is about once you see the answer, it's much more manageable. However, don't give them the answer. The rule is, again, when you are done, the card is flat, coin is balanced on top. That's it. That's all the rules are. This is kind of a bar trick, essentially. And with any good bar trick or puzzle like this, it's all about misdirection, okay? In the sense that you're saying it has to be flat, and it does have to be flat. But they'll start doing this. They'll start putting it on the table and start very carefully trying to line up the edge and try to line it right in the middle. And this is a loud activity, so when you have an entire classroom of people balancing forwards like this, it can be a little annoying.
I was getting ready to say, make sure you wear your earplugs that day.
Yeah, exactly. However you want to do it. Of course, if they do it on paper, it's a little less noisy. Anyway, let them struggle. Now, they are welcome to work in groups, to share information back and forth, to talk about it. They will be very frustrated. That's okay. Tell them up front, this is a frustrating activity. Don't give up right away. There is an answer. All of you will be able to get this done. Be creative. That's the important part. It's not about physical ability. It's about the creative thought process. Okay? And what will happen is someone will come up with the idea, someone will ask you the right question that you can give them a nudge to help it, and then it will spread like wildfire through your classroom, and then everyone will be able to get it within a few minutes. Okay, so I'm breaking my rule here. I'm telling you the answer because you're not here and I can't make you suffer in person. Here's the rule, or here's the answer. I said when you're done, the card is flat. I didn't say anything about when you start, the card has to be flat. So, fold the card, place the coin on top. Okay? Slowly pull the card taut. And then the coin is balanced. Okay? Now that didn't take very long once you have the answer. But you're trying to get them to come up with the answer. You have to use fresh index card this time, so if they see a crease in the card, it's all over in a few seconds. And you have not done the most important thing, which is work on persistence with your students. Make sure that they do not give up at the first sign of failure, that they work through the failure, that they are managing their own frustration levels so that they can still think and work. So again, and of course it doesn't have to be a crease, it could be just a curve or whatever. What's going on inside this is as you are slowly opening this up, the friction of the card edge and the coin face is just enough to vibrate this coin. You don't see it, but it's happening. To vibrate the coin so the coin finds its own center of gravity. And then it's already balanced. It's not you finding the center of gravity. That's incredibly difficult. Now, if your kid can balance it without having to fold it in half, then you should probably see a talent scout somewhere, because that kid's got some abilities. But, no one else can do it. But the coin will find its own center of gravity, and that's why you can pick it up even on this thin card edge and walk around with it and go from there. And then make sure to give your kids a fresh index card to go home with so they can talk to their parents and show them what they've learned. Okay? And mostly if they want to be mean to their parents and make their parents feel like they can't do it. But it also helps them talk about science and what a cool job you're doing in the science classroom. Okay, so that's the first one. That's balancing a coin on top of the card. Now, of course, the other thing that's going on is that we have literally balanced forces on that. The force of gravity is evenly balanced then by the upward force of the card, and because the card is sitting on the center of gravity for that coin, it's not toppling over. The next one uses a water bottle and a simple little ring. This is called a Inertia ring. We get it from a company called Steve Spangler. He's awesome. Anyway, again, this is all about persistence, and we don't tell our kids how to do this.
Right.
So, one small hex nut balanced on the top of our water bottle. This does take some work for your kids trying to get it straight. The water bottle is not cooperating very well. Sometimes the rings get a little tweaked. All right, so we want that hex nut to drop straight down into the water bottle. Now, Newton's first law says that, it's the law of inertia, says that objects at rest will stay at rest. I'm paraphrasing here. And objects in motion will tend to stay in motion unless acted on by another force. Now, what the goal here is to remove the yellow ring without hitting or touching the bottle, without hitting or touching the hex nut. And if you can do that, then suddenly the balanced force of the hex nut is gone, and gravity will pull the hex nut straight down through the neck of the bottle into the bottom. Okay? Again, this is the setup. You tell your kids how to set it up. You do not tell them how to do it. They'll need to figure it out. It's a lot of frustration with this one again. So build some time into it to get the kids to work through that frustration. In this case, what they need to do is they need to remove the ring without touching the hex nut. They cannot do this. They cannot pick it up, right? They can hit the ring, but they can't pick it up at all. Now, I'm going to try this. It's not going to work because it doesn't work all the time, but we'll see. So the easiest way to do this, the kids will want to hit it on the side and try to move it this way, for instance, or hit it front to back. Those can work. But the better way to do it is put your finger inside the ring and then pull it as fast as you can. So we'll see. We got 1, 2, 3. Almost. But you can see how this would work. If you remove the ring quickly enough and smoothly enough, then the hex nut has no choice but to fall in to the neck. All right. So let me explain how this works. If you hit it on the side, again, they can't see this, but you can tell that if you hit it on the side, what happens is the ring actually deforms and moves up like this, which means the hex nut now has some force acting upon it, moving up. Now, if it's still nice and smooth, it'll work. But anytime you add force to an object, you are potentially moving it around. What you want to do instead is you want to put your finger inside and you want to pull, because what the ring will do this. And for the briefest moment, the hex nut will sit suspended in air right above this. Gravity is still acting on it, but gravity has not had enough time to pull it down quickly. So you have a fraction of a second where this is floating in air. The hex nut has now been squeezed a little bit, and then when it's getting out of the way, now this will drop down cleanly. Now that's stage one, is the hex nut is on top. Okay? Stage two is the hex nut is in the bottom. Okay? Now they can't swing it left or right. Now they have to go forwards or back. In that case, they can use two hands to either flick it out or two hands to pull it back. And again, it doesn't work. Not the first time. It's all about persistence, right? Working through failure. Thank you, Samson. When they get it, and they will get it, because they're way more coordinated than we are. They will they'll get it straight, and then what will happen is you can get them, challenge them to do things like stacking multiple hex nuts on the inside and stacking them up on top. A friend of mine who is more coordinated than I am and had a lot of spare time one day for parent-teacher conferences that no one showed up for, she was able to stack 9 hex nuts, 5 below, 4 above, and get it done. So it is certainly possible. But again, law of inertia, so you're trying to move the ring without impacting the motion of the hex nut. And then once that balanced force is gone, gravity will pull it straight down to the bottom. Thank you.